everyone, welcome to Math Quiz. In this video, let me discuss about Fourier series for continuous function. For that, let me take an example. Expand f of x is equal to 1 by 2 product pi minus x as a Fourier series in an open interval 0, 2 pi and deduce 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus etc. that is equal to pi over 4. Let me first find out the Fourier series for the given function f of x is equal to, that is given function f of x which is equal to 1 over 2 product pi minus x, which is defined in the interval 0 less than x less than 2 pi. So you know already the general form of the Fourier series, which is of the form f of x is equal to a naught divided by 2 plus sigma n varies from 1 to infinity a n cos n x plus sigma n varies from 1 to infinity b n sin n x. Here a naught, a n and b n are constants. For calculating these constant values, we make use of the Euler's formula. A naught is equal to 1 over pi integral 0 to 2 pi f of x dx and a n is equal to 1 over pi integral 0 to 2 pi f of x cos n x dx and b n is equal to 1 over pi integral 0 to 2 pi f of x sin n x dx. Actually, we have discussed the same problem and we have find out the Fourier series for the given function. So I just give the link in the description box. So after calculating the value of a naught by substituting f of x equal to 1 divided by 2 product of pi minus x, we get the value of a naught as 0 and also a n is equal to 0 and b n is equal to 1 over n. So this was the problem we have discussed already. The link is given in the description. So now after substituting the values of a naught, a n and b n, that is for calculating all these values, then what we are going to do next? We have to substitute all these values in the given function f of x. So here a naught becomes 0, a n 0, only b n exists. So which means after substituting the values of a naught 0, a n 0 and b n is equal to 1 by n in the general form of Fourier series, we get f of x is equal to sigma n varies from 1 to infinity 1 over n sin n x. So this is what the Fourier series for the given function f of x is equal to 1 by 2 product pi minus x. So after finding the Fourier series for the given function, what we are going to do next? We have to find, that is we have to deduce this series from this one. So we have to deduce the series 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus etc. which is equal to pi by 4. So for that, let me recall the concept of convergence of Fourier series that we have already discussed, and I am going to give the link also in the description box. So here the function is also defined in the interval 0 to 2 pi, which means the function is defined in the interval 0, 2 pi, that is an open interval, which means the point 0 and 2 pi both are discontinuous, that is x is continuous at all points except at 0 and 2 pi. Look at here, we have arrived at the Fourier series, that is f of x is equal to sigma n varies from 1 to infinity 1 over n sin n x alone. So in most of the problems, if you are going to derive a sine series, means definitely if you just replace x by pi by 2, the point x equal to pi by 2 gives you the sine series in most of the cases. Okay, so just put x equal to pi by 2. So approximately pi by 2 is here. Am I right? So that is inside the interval. If it is inside the interval, means that is a continuous point. So these are the cases which we have already discussed under the topic of convergence of Fourier series. So the link is given in the description. So this is a continuous point. If it is a continuous point, then what we have to do? We just directly substitute the value to get the function value at that point. Okay, this is what the procedure we are going to follow. Okay, so put x equal to pi by 2, which is a continuous point. So after taking the point, first thing you have to verify is whether the point is a continuous point or discontinuous point. So if you substitute x equal to pi by 2 means that is inside the interval, which means that is continuous. So which is a continuous point. If it is a continuous point, then it will be very easy. What we are going to do, just replace here and here, just replace x by pi by 2. F of pi by 2 sigma n varies from 1 to infinity 1 over n sine n pi by 2. So f of pi by 2 here means the value of the function f of x at x equal to pi by 2. And just show you the table for your reference once again. So if it is a continuous point, what we have to do under convergence of Fourier series, we just replace the value directly, that is substitute the value directly. Okay, this is what the procedure we are going to follow here. So now, so for the function Fourier series f of x equal to sigma n is equal to 1 to infinity 1 over n sin n x dx, what we did already, we just replace x by pi by 2. To get the sine series, okay, to get the series, that is sine series, most of the problems we have to replace if x by pi by 2 means you get the series, okay, in the direction part. So f of pi by 2 is equal to sigma n varies from 1 to infinity 1 over n sine n pi by 2. Isn't it? Now, what is f of x? That is what the given function. So the given function is 1 over 2 pi minus x, right? So here f of pi by 2 is the value of the function f of x at x equal to pi by 2. If we replace x by pi by 2, since it is a continuous point, so you can replace this value directly. So that is 1 over 2 pi minus pi by 2. So in the function, you just replace the value of x by pi by 2, that's enough. That is 1 over 2 pi minus pi by 2 is nothing but pi by 2 itself. So it's a product with 1 by 2, that is pi by 4. So the value of the function f of x at x equal to pi by 2 is pi by 4. Okay. So next, sigma n is equal to 1 to infinity 1 over n sine n pi by 2. What we are going to do next is, we are going to just expand this series. Look at the problem. In the problem, we have to write down the terms up to first 4 terms we have to write. That is 3, 5, 7. Up to 7th term we are going to write. Okay. So now 5 by 4 is equal to sigma n is equal to 1 to infinity. First you have to replace the value of n by 1. So in these two places we have n. So 1 over n, 1 itself. Sine 5 by 2 plus, next replace n by 2 and just expand the series, okay. Sine 1 by 2 sine 2 pi divided by 2. The next substitute n is equal to 3, 1 by 3 sine 3 pi by 2 plus substitute n is equal to 4, 1 by 4 sine 4 pi by 2. Substitute n is equal to 5, 1 by 5 sine 5 pi by 2 plus 1 by 6 sine 6 pi by 2 plus 1 by 7 pi by 2. Since it is given up to 7th term, so I have to write 7th term. So in the question they have mentioned up to 7th term, so I have to write here up to 7th term of the series and then put etc. Okay, plus etc. So you know already the values of sine. Okay, I am just recalling the values. The value of sine 0 is 0 itself. Then next, sine pi by 2. The value of sine pi by 2 is 1 and sine pi is 0 and sine 3 pi by 2, that is 270, that is minus 1, and sine 360. Sine 360 degree or sine 0, both are 0. Okay, so these are all the values we have studied already. We just replace this concerned value with the function. Now, sin pi by 2. So the value of sin pi by 2 is 1 itself. So we have the first term pi by 4, that is pi by 4 is equal to, the first term is 1. Okay, next plus first term over. Coming to the second term, sin 2 pi by 2, that is 2 pi by 2 is nothing but sin pi. The value of sin pi is, what is the value of sin pi? The value of sin pi is 0. So the second term becomes 0. So plus 0. Coming to the third term, in the third term you have 1 by 3 sin 3 pi by 2. Sin 3 pi by 2 value is minus 1. Sin 3 pi by 2 value is minus 1. Minus 1 product 1 over 3 is minus 1 by 3. That is your next term. Okay. Next, coming to the fourth term. So sin 4 pi by 2. 4 pi by 2 is nothing but sin 2 pi. Sin 2 pi is nothing but 0. Sin pi 0, 2 pi, 3 pi, 4 pi, everything is 0. Next, fourth term becomes 0. Coming to the fifth term. Sin 5 pi by 2. Sin 5 times pi by 2 is nothing but 4 pi by 2 itself. Am I right? 4 times pi by 2 means 1 rotation over. So 5 pi by 2 is nothing but sin pi by 2. The value of sin pi by 2 you know already, that is plus 1. So plus 1 over 5. Coming to the next, 1 over 6 sin 6 pi by 2. 6 pi by 2 is nothing but 3 pi. Sin, already I told you, sin pi, 2 pi, 3 pi, 4 pi, everything 0. So this term vanishes, that is becomes 0. So the sixth term is 0. Coming to the seventh term, sin 7 pi by 2. The last term is sin 7 pi by 2. 4 pi by 2 means 1. Sin 7 pi by 2 is nothing but sin of 3 pi by 2. Sin of 3 times pi by 2. That is 4 times means 1 rotation over. So since it is periodic, that is 7 pi by 2 is nothing but sin 3 pi by 2. The value of sin 3 pi by 2 is nothing but, what is the value of sin 3 pi by 2? That is minus 1, isn't it? So that is minus 1 by 7 plus etc. Okay. So I am just write this right hand side to the left. That is 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 plus etc. which is equal to pi over 4. So we have deduced the series from the Fourier series f of x. Okay. Hope you got a clear idea about how to deduce the Fourier series. In case f it is a point we have chosen is a continuous point. Thanks for watching. See you all again in my next video.